Good afternoon to everyone. Uh, is Sanjay is here because when I am recording the session, automatically, yeah, Sanjay came back. Okay. Now, write on the problem. Prove that the area bounded by the simple closed curve capital C prove that the area bounded by a simple closed curve capital C is given by half n by 2 into integral over C x dy minus y dx. Okay, so this is the first part of the question. Hence find hence find that means using the above result to find the please write uh, hence find the area bounded by find the area bounded subdivision 1 bounded right here subdivision 1 by the parabola bounded by the parabola and y square equal to 4x parabola y square equal to 4x and its lattice vector. Its lattice rectum. Subdivision 2, area bounded by the ellipse. X square by a square plus y square by b square equal to 1. Okay, solution. So now I am going to ask you a question. So try to answer, because if you give the answer, you can learn in the classroom itself. There is no need to separately go and study these concepts. So by Green's theorem, so we know that integral over C pdx plus qdy equal to double integral over R, okay, qx, that is a dou q by dou x minus dou p by dou y into dx dy. My first question is, what is p, what is q? Anybody? Pragadesh, please tell.
P equal to minus y by 2.
P equal to minus y by 2. Very good. Q equal to x by 2. Very good. So usually students mistake பண்ணுவாங்க இந்த ஸ்டெப்ல. என்ன பண்ணுவாங்கன்னா, so they will write P equal to x, Q equal to minus y. So அது ஒரு mistake. Or otherwise they will write correctly, they will write P equal to minus y, but they missed this 2 here. Similarly, they will write Q, but they don't write Q. So these are the mistakes usually the students will do. But Prakash correctly. So P equal to, because P is what? P dx. So minus 1 y by 2, and Q is what? You can check it, dy. So x by 2. So okay. So we got P and Q. We need to find Qx and Py. Okay. So from this, what is Py? Py means dou P by dou y. Dou P by dou y is minus 1 by 2, and dou Q by dou x equal to 1 by 2. Okay. Now we need to prove, first part, we need to prove that area bounded by the simple closed curve C is this. Okay, now I am going to take this integral. Okay, that is 1 by 2 integral over C, 1 by 2 integral over C x dy minus y dx. Okay. By Green's theorem, this is equal to integral over R. Okay, this is actually pdx plus q dy form. So the right hand side of the Green's theorem is what? Dou q by dou q by dou x. Dou q by dou x is 1 by 2. Dou p by dou y is minus 1 by 2. So minus of minus plus. So 1 by 2 plus 1 by 2. 1 by 2 minus of minus 1 by 2 into dx into dy. So this is nothing but double integral over R into dx dy. So actually morning Sanjay told that, okay, this is nothing but area of the region R enclosed by C. Double integral dx dy over the region R is area of the a region capital R enclosed by curve C. So I proved that area bounded by or enclosed by simply closed curve C is equal to half of integral of C x dy minus y dx. Okay, so I proved the first part. So, so even you can write here like this. Okay, area. So I don't want to waste my time. So you can write. Okay, the next line you can write area of the region enclosed by the curve C equal to half of this. Okay. Now, first I will go to subdivision 2 and then I will come to subdivision 1 because I know that you know the area of the ellipse. So that's why I'll start from the known result. Okay. So what is the area of the result? Sorry, area of the ellipse. Area bounded by the ellipse. இங்கேயோ படிச்சிருக்கோம்ப்பா. கரெக்ட். யாரு? சாரி, பேரை கேட்டா ஏப்பா பயப்படுறீங்க? பிரகதீஷா. சாரி சாரி, எனக்கு கேட்கல, சுத்தமா கேட்கல. ஓகே ஓகே, ஏரியா பவுண்டட் பை த எலிப்ஸ். ஓகேவா? ஸோ 1/2. ஸோ பை யூசிங் த ப்ரீவியஸ் ரிசல்ட் 1/2 integral over C x dy minus y dx. Yeah. So okay, ellipse மாதிரி இருக்கும். ஓகேவா? நீங்கள் கரெக்டாக போட்டுருக்கீங்க. Okay, now what is the parametric form of the ellipse? X square by a square plus y square by b square equal to 1.
A cos theta b sin theta.
A cos theta b sin theta va Lakshmi Narayanan. Okay, so 1/2 integration x is equal to a cos theta, y equal to b sin theta. ஓகே, நீங்கள் சொல்ல நான் எழுதிட்டு இருக்கேன். ஸோ எக்ஸ் dy minus y dx. So 1/2 integration x is what? A cos theta into dy. If you differentiate y you will get b cos theta to d theta minus y. Y is b sin theta and dx is minus a sin theta into d theta. Minus a sin theta into d theta. Theta varies from where to where? Theta varies from where to where? Aditya? Yeah, Pradesh, please tell.
0 to pi, sir.
0 to
Pi, sir.
0 to pi வரும்.
0 to 2 pi.
Yeah, 0 to 2 pi is correct. Yashashwini. Okay. Okay, va? So start from here. Okay, va? 0 to 2 pi. Okay, va? 0 to 2 pi. So now if we simplify, you get AB here also AB. So AB is common. So AB by 2. Integral theta varies from 0 to 2 pi. Cos square theta minus into minus plus sin square theta, that is 1. Okay, I will write one more step into d theta. So AB by 2, this is 1. To integrate d theta, you get theta 0 to 2 pi. So you get AB by 2 into 2 pi minus 0. 2 gets cancelled. We got the area of the ellipse is pi AB. Okay. So second part is over. Now, first part. First part is what is the question? I'll check it once again. We should find the area bounded by the parabola y square equal to 4ax and its latest rectum. Okay, so first we need to draw the diagram. So if we see the diagram, then we can uh, uh, find what we need to find exactly. Area bounded by the parabola and its latest rectum. Well, actually, this is equal to, by subdivision, first part is equal to integral over c x dy minus y dx. So I am using the result I proved. Okay, that's why this is equal to 1 by 2 x dy minus y dx. Okay. Now, so diagram. So y square equal to parabola y square equal to 4ax. Square equal to 4ax, and the latex rectum is passing through the focus. Take this is the focus S a comma 0. So this is we'll take L. This is L dash. Yeah, this is the latex rectum. So where L equal to a comma, because this is the parabola y square equal to 4ax. Okay, a comma, this point is 2a. You can substitute y square equal to 4a square, 4ax. Y square equal to 4ax. So if this is 2a means this point is a comma minus 2a. So if you can substitute the x is equal to a, so y square equal to 4a square, y equal to plus or minus 2a. So plus 2a come here, minus 2 will come here. Okay. Now, area bounded by the parabola, okay, and its lattice rectum means, so this is your R, this portion and this portion. Okay, so this is your R. This is your C. Anti-clockwise direction. Already I told that he is in the anti-clockwise direction. This is the line x is equal to A. Okay. So this is your R. Now, okay. So I should use this result only. Okay. So 1 by 2 integral over C. I divide the C into two parts. One is this is origin LO L dash, along LO L dash. Integrand is what? X dy minus y dx plus LO L dash plus L dash S L along this straight line. L dash S L x dy minus y dx. This 1 by 2 is common for both the integrals. Okay. Now, along the LO dash, this is on the parabola y square equal to 4x. So that's why I'll write this is x is equal to y square by 4a. Y square by 4a. Or you can write dx is equal to 2y by 4a into dy. Or dx is equal to y by 2a into dy. So everything I should write below this integral. Similarly, uh, or you can omit this step, directly write this step. Because if you write like this, okay, so only these and this is enough. Enough. Okay, there is no need to write this step. Okay, for understanding purpose, I wrote here. So next, L dash SL. L dash SL is the line x is equal to a. So x is equal to a means dx is equal to 0. Okay, dx is equal to 0. So now you need to substitute these values in this integral and you should tell in the next page. This Parasaran is here. Parasaran? No. Okay. So, which is equal to 1 by 2 integral. What about the, okay, I'll come to the limit part later. What is x? X is y square by 4a, okay, square by 4a into dy, okay. So even I'll take dy comma, okay, I'll write dy, okay, dy minus y. I'll write everything in terms of y. Dx, what is dx? Uh, y by 2a into dy. Y by 2a into dy. Okay. So I think this is over. Okay, sorry. So due to electricity cut, I lost my connection. Can you hear my voice properly now?
Yes, sir.
Yes, sir.
I don't know whether the video will come. Okay, let us check later. So I think we discussed up to this. So y into dx. Dx is y square by 2a into.
Presentation is not visible.
Sorry.
Your presentation is not visible.
Oh, not visible. Okay. So I need to share my screen. Okay. So, so I think I wrote up to this step minus okay minus y dy and then plus integral L dash SL. L dash SL is what x is equal to a and dx is equal to 0. Dx is equal to 0 means this is 0. So x is equal to a. So integral a dy. Okay. So integral a dy. So plus so 1 by 2. I am because 1 by 2 is common. So I'll write here. Now what about here? What are the limits for y? And what is the limits for y here? So can anyone tell? Ly L dash. What is the limits for y?
So
2a to minus 2a, sir.
Yes, 2a to minus 2a is correct. Right here. Y equal to 2a to minus 2a. And what about and here in this line here y varies from minus 2a to plus 2a. Okay. The remaining part is calculation. So simplify 1 by 2 integral 2a to minus 2a. So we get y square by 4a plus y square by 2a into dy plus 1 by 2 a by 2. If you integrate dy, you get y. Limit is from minus 2a to plus 2a. So 1 by 2. Okay. This is actually minus r. This is minus y square by 2a. So integral 2a to minus 2a. This is minus y square by 4a into dy. So plus a by 2. Upper limit is 2a. Minus of minus 2a is plus 2a. So get minus 1 by 8a. If you integrate, you get y cube by 3. So limit is from 2a to minus 2a plus this is a 4a square by 2a by 2. Okay, so finally you get minus 1 by 24a into minus 8 a cube minus 8 a cube. Both of them are minus 8 a cube. So please check it. Upper limit minus lower limit plus 4a square by 2, 2a square. Okay. So this is 16 a cube by 24a plus 2a square. So we get 2 by 3 a square plus 2a square. We get 6 plus 2 8 a square by 3. So this is the area. I think we got everything for this column. Okay. So now we'll move to the second column. Verify Green's theorem. In the plane integral over c 3x square minus 8y square into dx, okay, plus 4y minus 6xy into dy, where c is the boundary of the region, where capital C is the boundary of the region defined by y square equal to x and y equal to x square. Actually, similar type of problems you solved already in the first semester mathematics. Actually, these types of curve. So if I draw the curve, you can know. Okay, I think the double integration you studied, change of order of especially in change of order of integration, you studied this. Okay. So first, before going to the solution, first I'll draw the diagram. So what is the two curves? Y square equal to x and x square equal to y. So this is y square equal to x and this is x square equal to y. So this is the region between these two is this is the region. Okay, this is our R, capital R. This is the origin 0, 0. This is I will take A. So please find the point A, intersection of these two curve. Do it and tell me what is the intersection point. And already I told that your C should be anti-clockwise direction. So that's why I'll take arrow in the anti-clockwise direction from here to go to A. Similarly, this direction, anti-clockwise direction. So this portion OA I will take C1, AO I will take C2. Or you can keep OA or AO. Okay, well, so it is better to put C1, C2, then you can easily identify. Because OA, AO means sometimes both of them are, you feel it is same. Okay, that's why I'll write here C1, here C2. Okay. What about the point A?
1,
1, 1 is correct.
1,1.
Yes, correct.
Yes, sir.
Yes, correct, Krishnan. X is equal to actually y square. X is equal to y square. Similarly, we have what? Uh, y equal to x square. So we have these two, x is equal to y square, y equal to x square. Okay. So the intersection of two. So x is equal to y square. Okay. So y square equal to what? X power 4. So from this x power 4 minus x is equal to 0. Okay. So this implies if you take x common only, you'll get x cube minus 1 equal to 0. So this implies x is equal to 0 and x is equal to 1. Okay, if x is equal to 0 means y equal to 0. X is equal to 1 means y equal to 1. So the intersection point is 0 comma 0 and 1 comma 1. So A is 1 comma 1. Write 1 comma 1 here. Okay. So this is a point here. So now, as already told that here we need to verify. So it is better to do the right hand side. So right hand side of the Green's theorem is double integral over R dou q by dou x minus dou p by dou y into dx into dy. Okay. So double integral. Okay. Ramalingam, can you tell what is dou q by dou x? What is q?
Yes, sir.
Q. What is q? 4y.
Q
Yeah.
is Q is 4y minus 6xy.
Okay. P is 3x.
3x square minus 8y square.
Okay. So I need qy. Qy is what?
Qy is 4 minus 6x.
Qx. Sorry. I need qx.
Qx is minus 6y.
Oh yeah. Qx is minus 6y. Minus of py.
Minus of py is minus 8y.
Minus 16y.
Minus 16y.
Yes, correct. Okay, into dx dy. Okay, thank you, Ramalingam. So now we need to find the limits. Okay, so limits for x. Yeah. So Ajit Kumar is here. Okay. Shiva Somnath. Vignesh, sir? Yeah, Vignesh. Okay, Shiva Somnath. What about the limits? Can you tell the limits? How to find the limits here for x and y? Okay, so I will. Anybody knows how to find
0 to root x, sir. 0 to root x.
0 to
Root x.
is it correct? Because I will write the portion here. Okay, it is not clear. That's why I will write only that portion.
y square to root y, sir.
Y square to root y.
So I will write only that portion. So this is our region. Okay, actually, yeah, this is y square equal to x. This is y square equal to x. Okay, this is x square equal to y. So here, what is x? What is x here? What is x here? Y square. So y square 2. I think somebody told that. Okay, here what is x? Here x is root y. Okay. So this root y square to root y, and you should move a strip from strip from here to here. So this is the origin 0, 0. This is 1, 1. Okay. What about the limits for x? Y. Sorry, y.
X square root x.
0 to
Y,
0
0 to 1. Y very strong. The outer limit is always a constant. ஓகேவா? outer limit is always the inner limit தான் எப்படி இருக்குமா variable இருக்கும். So outer limit is always constant because you should move the strip from here to here. அப்ப okay in the end in the strip moves in this curve. So y varies from here to here means y varies from 0 to 1. Okay. So if you have any doubts, you can ask to me. Again, I will explain. So this is the crucial steps here. Once you find the limits, everything is easy. Okay.
Sir, can you explain y limits?
Huh? Y limit.
Y limit. Yeah.
Okay. Okay. So are you got how to find the x? X.
Yes, sir.
Okay.
Yes.
Okay. So actually, you should move the strip. This is the strip parallel to x-axis. So initially, the strip எங்க இருக்கும்னா இங்க இருக்கும். Okay. So I should move the strip like this. Move பண்ணிட்டே போகணும். So if you move like this, here what is y? Y is 0.
0.
In this end. Okay. So it is traveling like this. It is going like this. It is going like this. It is going like this. So it will end here. Finally, it will end here. So x varies from here. It is what? X is 0. Here x is y is what I told that here y is 0. Y is 0 and here what? Y equal to 1. So you may ask, so why don't we take a strip parallel to x-axis? Can we take a strip parallel to y-axis? Okay, you can take parallel to y-axis also. So if you take strip parallel to y-axis, Kirtana try to tell what is y here. The integrand is same. I just put dot. If you tell the answer, you can understand easily. That's why I'm asking again to you. What about y? What is y here?
0 to
y means, again I will draw the diagram here. Okay. So instead of taking strip parallel, you should take vertical. Okay. So this is the curve. This is the curve actually what? Sorry. Y square equal to x. This is y square equal to x. This is x square equal to y.
Then from root x to x square.
Y equal to root x.
Root x to x square.
Okay, correct. And you should move the strip from initially here. Next, you should move like this. If you move like this, okay. So here, what is x? What is here? What is x here?
0 to 1.
Yeah, x is equal to 0 to, it is moving like this, finally it's going with here. Or you can take in this path also. Okay, x varies from 0 to 1. So I think now you got it. So maybe you can try this method also. You will get the same answer. Okay, thank you.
Okay, sir.
Now y equal to 0 to 1. So this is actually 10y dx dy. I missed one integral. Okay. So this is equal to integral 0 to 1 y square to root y. Okay. So this is equal to 10 into 0 to 1. I should integrate with respect to what? X. X means you should keep y is constant. X y square to root y into dy. Okay. So this is equal to 10 integral 0 to 1 y upper limit. Anybody got the answer? Root y.
3 by 2, sir.
3 by
3 by 2 r. Okay, 3 by 2. Very good. So try to get the right hand side, left hand side also. Those who finished right hand side, left hand side also you can try. Okay. So okay, I think I am here. X is root y minus y square, okay, into dy. Now multiply by this y. So y power 3 by 2 minus y cube into dy. Minus y cube into dy. Okay, now integration 10 into y power 5 by 2 divided by 5 by 2 minus y power 4 divided by 4. Limit is from 0 to 1. Okay, so 10 into, you should substitute 1. So 1 by 5 by 2 is nothing but 2 by 5 minus 1 by 4. Lower limit is 0. So 10 into take 20. So 8 minus 5. So you get 3 by 2. This is the right hand side. So now left hand side. Left hand side is integral of C. This is the problem. Actually, PDX plus QDY. So this is the left hand side of Green's theorem for the closed curve C. I will write that is integral over C. P is 3x square minus 8y square into dx plus 4y minus 6xy into dy. Yeah. So now this is, I split this C into two parts along C1, along C2. So along C1, okay. So 3x square minus 8y square into dx plus 4y minus 6xy. This is along C1 plus along C2 3x square minus 8y square into dx plus 4y minus 6xy into d. So call this is equation 1. Okay, first on C1, I'm going to find separately here on C1. Okay, so can you tell on C1 what is the equation of C1? Yashashwini, what is the equation of C1?
Y square is equal to x.
Correct. This is actually C1. Okay, this is what? X square equal to y layer. C1, please check it carefully. Is it correct? X square equal to y then?
Yes, sir.
Okay. So on C1, x square equal to y, you can write, or y equal to x square. Both of them are same. So dy equal to 2x into dx. So x varies from where to where? On C1, from 0 to 1. X varies from 0 to 1. Okay. So now I will take this integral. Okay. Integral over C1 into 3x square minus 8y square into dx plus 4y minus 6xy into dy. So which is equal to integral. So we know that I'm going to convert everything in terms of x. So 3x square minus 8 y square. What is y square? Y square equal to x power 4 into dx plus 4 y is x square minus 6 into x, y is x square, x into x square is x cube into dy. dy is 2x dx. And we know that x varies from in C1 0 to 1. Now simplify 0 to 1. 3x square minus 8x power 4 plus 8x cube minus 12x power 4, yeah, into dx. So you get totally how many? 20, yeah. Okay, so 3x square plus 8x cube minus 20x power 4 into dx. So integrate and get the answer. So 3 into x cube by 3 plus 8 into x power 4 by 4 minus 20 into x power 5 by 5. Limit is from 0 to 1. So 3 gets cancelled. So 1, 8 by 4 is 2, 20 by 5 is 4. So lower limit is 0, 3 minus 4 is minus 1. So this is actually over C1. So next we need to find the over C2. Interval over C2. Okay, it is better to write on C2, not again, that's no need to write. On C2. Dikshita, what is the curve C2?
Y squared equals to x.
Yeah, y square equal to x or x is equal to y square. Okay. So this implies dx is equal to 2y dy. Yeah, 2y dy. What about the limits C2? Y varies from where? 120. Check pannu hoda. Y varies from where to where? On C2. Yes, you are correct. 120. Yeah, y varies from in this direction. 120. Okay. So now integral over C2. Okay. What is the integrand? 3x square minus 8y square into dx plus 4y minus 6xy into dy. Now just you need to substitute these values. 3x square. 3x square is y power 4 minus 8y square into dx. Dx is okay 2y dy plus 4y minus 6 into x. X is y square minus 6y cube into dy. So y varies from 1 to 0. The students will do the mistake here. They will write 0 to 1. They should be a little bit careful. So you should see the direction here. Okay, so y equal to 1 to 0. So 6 y power 5 minus 16 y cube plus 4y minus 6 y cube into dy. So remaining is just integration and substitute the limits. So 6 y power 6 by 6 minus 16 y power 4 by 4 plus 4 y square by 2 minus 6 y power 4 by 4. Limit is from 1 to 0. So we'll get 6 by 6 is okay. Upper limit is 0. Yeah. Minus lower limit 1. So here 1 minus 4 plus 2. 1 minus 4 plus 2 minus 3 by 2. So you get 3. So minus of minus 1 minus 3 by 2. Okay, so you get 1 plus 3 by 2. 1 plus 3 by 2 is 5 by 2. So this is actually I need to add. Finally over C. Okay, so over C, I'll put dot. This is equal to over C1. I'll put a dot here, and then you note the dot launch it below there. Okay, so dot means you should write again 3x square minus 8y square into dx plus 4y minus 6xy into dy. Yeah, that is a 3dx plus qdy. 3dx plus qdy. Yeah, so that is equal to here it is minus 1 plus 5 by 2. We get 3 by 2. So I think we got the answer. Time is nearly 1. Okay, so I should stop here. So I need a suggestion from you. Either I'll take tomorrow, I think tomorrow 7th hour, 7th hour, because the duty is initially it was 3 to 5. Now it is changed 12 to 2. So I am ready to take 7th hour, but there is one more option. Wednesday, I think you have first hour, I think the third hour, I think free. I don't know exactly, but out of these 2 hours, which hour you prefer? I don't take both hours. So either tomorrow 7th hour or Wednesday first hour or third hour. So just give your suggestion, and then I will 9 to 10 mechanical class Wednesday. Okay. So it is better to take tomorrow. Okay, so tomorrow I will take 7th hour. Okay, thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, everyone. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.